Hello everyone, welcome back to my YouTube channel Code with Aryan and to the data structures and algorithm course using Java. So in the last lecture we learned the basics of algorithm analysis, what is an algorithm, what are the characteristics of good algorithm and why do we need to analyze an algorithm. So today we are going to learn the following topics. So today's topics are time and space complexity, running time calculations, and frequency count method, which we will use in calculating running time of different functions. So this will contain a lot of functions and we will see those in this lecture itself. So whenever we are writing an algorithm, two questions should naturally come to our mind. First, how much time will this algorithm take to execute? And second, how much memory will it consume while executing? So these two questions are answered by the following two concepts: time complexity and space complexity. Time complexity, in simple words, tells us how running time of an algorithm increases as the input size increases. That's it. For example, suppose I have an array of 10 elements and I visit every element once. Obviously, I have to do some work to visit each element. Now, what if I increase the element size from 10 to 100? Obviously, I need to do more work. But what if the size of array was 1000? I will need to do even more work. So, as the input size increases, the amount of work done also increases. This relationship is called time complexity. So, that's it. There is nothing more about time complexity. But yeah, one question might arise that if it is time complexity, why don't we just use clock time or stopwatch to measure the time in seconds or milliseconds? It is because execution time depends on various factors such as CPU, RAM, programming language, compiler, and many more other factors. For example, if someone is writing a code in Python and someone is writing a code in Java, the Python code might be faster and the Java code might be slower, or vice versa, even if both the algorithms are same. So it depends on the language, CPU, RAM, and many other factors. Therefore, we don't usually use the actual time. So now, along with time, there is another thing that we care about while writing programs: space complexity. So whenever a program runs, it uses memory. Sometimes it needs a very little memory, or sometimes it needs a lot of memory. So just like the running of time of an algorithm, we also study how much memory it uses. In simple words, space complexity tells us how memory usage by an algorithm changes as the input size increases. So again, we are not talking about memory in megabytes or gigabytes. We are only interested in how memory requirement grows. So suppose I create an integer array of 10 integers and another array of 100 integers. Which one uses more memory? Obviously the one with more number of elements. So as the input size increases, the amount of memory consumed also increases. This is what space complexity studies. So for an example, let us take the same example we took in the last class. Here we are swapping two numbers a and b. So as we discussed in the last lecture, every basic operation takes 1 unit of time. So assigning a value of a to temporary will take 1 unit of time, assigning the value of b to a will take 1 unit of time, and assigning the value of temporary to b will take 1 unit of time. So total there will be 3 units of time. And since there are 3 variables, temporary, a and b, there will be 3 units of space consumed. Also, this is this temporary variable we defined ourselves. And as because this 3 is constant, we write it as order of 1. we find so this 3 units of time we found is also called time function in terms of n, and we got it as 3. Since this is constant and it doesn't have a term of n, so it can also be written as n power 0, or which is just constant. So we write it as order of 1. So the time complexity of this program is order of 1. And let's talk about space complexities of some common data structures. So a list or array of n elements will have order of n space complexity because there are n elements. A matrix having n cross n elements, that is total n square elements, will take order of n square time complexity, and a tree of n nodes will take order of n space. So the next topic we are having is running time calculations. So what is running time? It is simply how long a program takes to execute. It is not the actual clock time as we discussed previously because of the CPU, RAM and other factors. It is just the number of operation an algorithm does. So the next topic is unit cost assumption. It is one of the easiest topics. So in here it is said that every basic operation takes 1 unit of time. For example, we are assigning a equal to 10 and b equal to 20. It is taking 1 unit of time each, and we are subtracting, or maybe we are adding a and b, then it is also taking 1 unit of time, since addition takes 1 unit of time, and this addition takes 1 unit of time. Also this assignment takes 1 unit of time, so total 2 units of time. Similarly, comparison, increment, decrement, print, etc. all takes 1 unit of time. And now we are on the frequency count method. So it is just the number of times each statement executes. We will just simply count how many times a statement is executed, and just like previously, we will find the time complexity using units of time, counting each one by one. So this is an assignment, so it will take 1 unit of time. Second example, these are 3 consecutive statements. So these will take 1, 1 and 1 unit of time. So it is, the time function will be 3. Here the time function was 1, and since it is constant, the order was 1. It was also of order 1. So for single statement or consecutive statements, both will be of order 1. We will just add these. So the next part is if-else statements. So notice one thing, whenever we are checking this condition, either this block will be executed or this block will be executed. Never both. So whenever this part is true, which means whenever a is greater than b, this will be executed, and whenever b is greater than a, this will be executed. Let's take for example a is greater than b. Then this will take 1 unit of time, and the comparison will take 1 unit of time. So total it will take 2 units of time. Then the time function will be 2, and the order, and since it is constant, the order will be 1. Now let us move to one more example. In here also, if we analyze, either this part will be executed or this part will be executed. Let's take for example this part is executed and this part is true. So the comparison will take 1 unit of time, this increment will take 1 unit of time, and this increment will also take 1 unit of time. So in total we will have 3 units of time. The time function will be 3, and since it is a constant, the order will be order of 1. What if this part is true? Even if this part is true, then also the comparison will be done. So comparison will take 1 unit of time, and this increment will take 1 unit of time. So this will have 2, units of time, and the time function will be 2, and order will again be 1. But since the time function has a difference, so this type of problem which will naturally lead us to best and worst case, which we will study in upcoming few lectures. So the next topic is single loops. So in here, this part is initialization, this part is comparison, this part is increment, and this is the operation inside this for loop. So let us dry run this code once. For example, let's take n equal to 3. First we initialize the value of I from 0, and we are checking if I is less than n, that is I is less than 3. So 0 is less than 3, so this will be executed once, and this will print I, so it will be printing 0. Here we will write our output. Then it will increment, so incrementing will be done once, and then I will become 1. It is still less than 3, the comparison is done, it will again print 1 and again increment. Now after incrementing it becomes 2, so 2 is, we will compare 2 is less than 3, so yes, 2 is less than 3, I plus plus, then it will print I, which is 2, and it will increment again, so it incremented again. Now it will again check if 3 is less than 3 or not, but here 3 is not less than 3. After comparing, the loop will end. So what did we get here? This comparison ran 4 times, and this increment ran 3 times, and this initialization ran once. So we can write it as this ran 1 time, this ran 4 times, and this ran 3 times when n was 3. So if we generalize this, the initialization will be 1 time, comparison will be n plus 1 times, and incrementation will be n times. So let us write it as 1, n plus 1, and n. This also ran n times. This statement also ran n times, so we will write it as n. So total loop ran 1 plus n plus 1 plus n plus this n. In total, it will be 3n plus 2, which is our time function. And since it is of the order n, the highest degree of n is 1, the order of time complexity will be order of n. Let's take one more example, and this is a tricky question because in here we are not taking it as n. So if we try and run this code, this will run 100 times, not n times. So the order will not be n, it will be O of 1, because if it is running 100 times, it is still constant, so the order will be constant and the time function will be constant. So our next part is consecutive loops, and these are 2 loops. Notice these are not nested, or these are not in one inside another. This is just in the same line or indentation as this and this are in the same line or same indentation. So these are 2 independent loops of and 2 consecutive loops. So we just now saw for single loop, the time function comes as 3n plus 2 and the order comes as O of n. Now similarly, this loop will run n times, because if the input is n, it will run n times. For example, let's take n equal to 3. So this loop will print 0, 1 and 2, and for this also, this j loop also, this will print 0, 1 and 2. So the total output will be 0, 1, 2, 0, 1, 2. This will be the total output of this code. So now this loop ran n times, and this loop also ran n times, because this loop ran 3 times and n was 3. So this loop ran n times. So this total code will run 2n times, because we will add these two. So notice, whenever there is two consecutive loops or consecutive statements or any consecutive assignment, we add the number of times the loop is running. So here also we are adding, and the final result we are getting as 2n. Since the power of n is 1, so it will also be order of n. So the time complexity for this also will be order of n only. Now next, let us move to the next topic, which is nested loop, and it is a little more important and a little more tougher to understand. Here the for this for loop is inside this one. So we need to focus, and let us take an example n equal to 3 and try to understand this loop. So this n equal to 3 and this n is also 3. So we'll initialize I equal to 0 once, and it will check if I is less than 3. Yes, it is less than 3. It compared one time. So this will go inside the loop. So our pointer or whatever, if this condition is true, will go inside the loop. So inside this loop we are having another loop. Here we initialized j as 0. So this initialization step took, and next we will compare once if j is less than 3 or not. Yes, j is less than 3. So we will, if this is true, then we will again move inside the loop and do the statement whichever is mentioned inside the loop. So it is asking us to print I and j. So we will print 0 and 0, since I and j is 0 and 0 for this time. Now if this statement is done, we will increment this j, and then j will become 1. So we incremented it once. Now again we will check if j is less than n. So 1 is less than 3. Yes, it is true. So we will again be printing this 0 and 1. Now again, after completing this statement already done twice. So after completing this statement, we will again increment j to 1, j by 1. So now j will become 2. So now j is 2, and we will again check if j is less than 3 or not. So j is 2, and yes, it is less than 3. So we will again come inside the loop and perform the operation inside the loop, which is printing I and j. So we are printing 0, 2. Now after doing this statement, it will again execute this. It will again go to increment this. So now j will become 3, and this incrementing operation takes place. So now it will compare again that if this was already compared previously. Now it will compare the fourth time if 3 is less than 3 or not. It will compare it if 3 is less than 3. Here we compared if 0 is less than 3. Here we compared if 1 is less than 3. Here we compared if 2 is less than 3. Now we are comparing if 3 is less than 3. But no, it's not less than 3. So we will move out of the loop. And when this part of the statement, like this part of this loop is done, it is like a function, or it is like an operation for this loop. So when this is done, we will move to this loop and increment this one. So now we are incrementing I from 0 to 1. So now it ended, our j ended. Now we incremented I to 1, and now our I is 1. Now we will check if I is less than 3 or not. Is it 1 is less than 3? Yes. If this condition is true, we will again move inside. So we will again do the same operation for I equal to 1. So what will be the output? First, when I is 1, we will again initialize j to 0. Now check if j is less than 1 or not. Yes, it is, because j is 0, j is less than 3. So it will print I comma j, which is 1 comma 0. Now again j will increment from to 1, and similarly 2 and 3, it will check 3, but 3 will not be satisfying the case, it will again come out, and again we will increment I. Similarly, then I will become 2, so the output will be 1 1 1 2. So then I will become 2, the output will be 2 0 2 1 2 2. When I will become 3, after doing this loop thrice, like after coming into this loop thrice, when again we will come to increment this I, the I will become 3, and when we will go to check if I is less than 3 or not, this loop will become, this condition will become false, because 3 will not be less than 3. So in total we will get this output, and this output is from this output we can check how many times the loop ran. So once, twice, thrice, 4, 5, 6, 7, 8, 9. So this loop ran 9 times and our n was 3. So can we derive a relation between n equal to 3 and this number of times this loop ran? Yes, this is n square. So we can simply say the function is n square, or just order of n square, because the order of this is n square. So so we found out that this is n square. That means this inside loop, let me clear the board first. So as we saw, this inside loop ran 9 times, but this loop only ran thrice because this ran n times. That means it ran thrice, and for each time this loop ran thrice. So if it ran once, this ran thrice, again it ran twice, it ran again thrice, and when this ran for third time, this again ran third time, like 3 times. So for each time this loop, outer loop ran, this loop ran 3 times. So in generalized way, we can say that this loop ran n times and this loop ran n square times. Now the time function will be f of n equal to this n plus n square, n plus n square. So what is the degree? The degree of this function is the highest power of n, which is n square. So our time complexity will be of order n square. So we will write it as order of n square. I hope you understand it. So the next topic is 3 nested loops. This one is similar to the previous one, just it is that here there are 3 nested loops. So as we saw in the previous one, the outermost loop runs n times, the inner loop or the second inner loop runs n square times, and similarly the third inner loop will run n cube times. We can take an example for n equal to 3. First I will be 0 and j will be 0. Let's write it in an indented way so that we can understand it better. So for first I equal to 0, and then j will also be 0, because when I is 0 we will enter this loop, j will be 0. Now since this condition will be true, we will enter this loop. Now k will be 0, k will be 1 and k will be 2. When it will increment again, it will give the condition is false. So now this will move to this. That means j will increment from 1. So j will become 1, Now again it will enter k loop, k will become 0, k will become 1, k will become 2. Now again it will go to j loop and j will become 2. For this k will be 0, k will be 1, k will be 2. Similarly this for I equal to 1 and I equal to 2. This will be same. For I equal to 1, j will be 0, k will be 0, k will be 1, k will be 2. Now j will be 1, k equal to 0, k equal to 1, k equal to 2. Now j will be 2, k equal to 0, k will equal to 1, k equal to 2. And similarly for I equal to 2. So in here we can see the k loop. Let's write it and understand. For I equal to 2, j will be 0. For j equal to 0, k will be 0, k equal to 1, k equal to 2. Now j equal to 1, k equal to 0, k equal to 1, k equal to 2. And for j equal to 2, k equal to 0, k equal to 1, k equal to 2. So let us understand and count how many times each loop ran. So in here we can see the number of times k loop ran. This is 3, 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 and this is 3. So the k loop ran 27 times. And now let's check how many times the j loop ran. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So the j loop ran 9 times. And simply the I loop 1, 2, and 3. So the I loop ran 3 times, which is n square, and n cube. So the time function will be n plus n square plus n cube will be the time function, and the highest degree of n is 3. So the order will be O of n cube. This is how we find the time complexity of nested loops. And the next topic is independent nested loop, which just means that this variable and this variable will be different. This loop, if this loop depends on n, this loop will depend on m. So can you tell me how much time will this take? So this loop will run n times, but for each time this loop runs, this loop will run m times for each time outer loop runs. So for example, let's take n equal to 2. So when the outer loop runs one time, first time, the inner loop will run m times. And when the outer loop will run second time, the inner loop will again run m times. So it ran 2m times when n was 2. So can we derive an expression for this? Yeah, this 2 can be written as n. So the inner loop ran n into m times. So the time function will be n plus n into m. But as we cannot determine, as we can understand that this is bigger than this, so the order will be O of n into m. For now, let's keep it till here, and the next topics we will do in the next lecture. If you liked the video, please like, share, and subscribe. See you in the next lecture. Happy coding.